Good afternoon or good morning, depending on where you are. I'm Jason Fox, back again for the latest session on this FIWARE training. And today we're going to be covering connecting to legacy systems, connecting to IoT, connecting to things outside of a context broker, basically. The presentation I've got here, which is going to be approximately an hour and a half, is specifically to do with IoT. And then at the end, after a short break, we'll deal with connecting to other systems. Well, some of that was covered in the previous session. Where are we? Here we go. So, where are we? Here we go. I've got my things on here. That's slide 2. Okay, so whenever you are creating an NGSI-LD specific system, and this is not NGSI v2, specifically NGSI-LD, the first thing you need to do is you need to define your world. You need to make sure that you've got a complete list of all the entities in your system and all the attributes of those entities in your system. So as you can see here, from my little list here, what I've got here is on the little tutorial thing. It's a small agricultural system. I have got things like device, like filling level sensor, like cow collar, like temperature sensor. Everything, every entity type I want should expand to a full long IRI. In this case, what happens is that the right-hand side has got a namespace followed by a colon followed by whatever you're calling it. So they tend to be very similar. And according to JSON-LD rules, this means it's expanded by whatever names you call it beforehand. So obviously, in our particular case, we've got a namespace called FIWARE, and that will be a FIWARE data models hash whatever. You've got one for schema.org. So for your example, your address would be a schema.org address. You just type schema.org :address. And whatever's custom to you, you can put using whatever. I've got example here, example.com. You can put that into your data models. Where you've got some strange oddities which aren't currently existing in your data model, like for example heart rate. For example, I looked for an existing ontology, and if you go to that bioontology.org, you will find that heart rate is well defined by them. So I'm reusing existing IRIs for the mapping, because what you must remember is that if you go back and don't put a mapping from your short name to a long name, it will fall back onto the default context. And that will make absolutely no difference if you're just dealing with your system internally. However, it means that if you're interested in data sharing, it's pretty useless, because obviously there's no real use case for a default context / heart rate in coming from Etsy. So it's important to go out and define your world properly. Now, this is a bit of a pain, to be honest. It's something which needs to be done, and it's something which needs to be done in a fashion such that you create a proper readable file. So as you would expect, a lot of this can be automated or stolen directly off the off the internet. If I briefly bring up a browser. I bring up a browser. You can see this is schema.org, who create an awful lot of IDs. They will allow you to just create their entire schema, and you can just download the damn thing. It's just got all these definitions, and it's just already they already exist. So if you want to have use a UK non-for-profit type organisation, charity, in your system, you can just copy that bit directly to your phrase. If you go over to smartdatamodels.org, let's look at something in smart water, let's say. Okay, we're in smart water. You can go straight into, say, water quality. You will find that water quality observed. There will be somewhere in here, I think it's examples. Is it examples? I can't remember now. But again, there will be a mechanism for generating the at context file. Now, if you can just, even if you just go over to, say, just pick water quality again. I think this is generated. That's right, it'd be the docs, wouldn't it? Maybe I should go for a different domain because I'm happier with device. No device works. Censoring device. Censoring device. If I go here, you've got a device, which is that one. And there's an interactive specification, a Swagger specification. From the Swagger specification, there's a little tool which you can use, which is actually in one of the tutorials, which will actually generate the at context for you. So from this definition of all these attributes here, you would be able to generate, and I'll try to find the file tutorials. I'll just bring up the tutorial. Just a minute. Actually, no, I'll do this. I'll change my mind again. I can go to NGSI. Read on the NGSI-LD tutorials. You can look at understanding at context. The very first tutorial, it will actually generate from there. It will actually generate a file for you. You can see that's so. Here you would take. Where has it gone? There we go. This is my this is the definition of my world. For example, I have got devices. I've got temperature sensors, filling sensors, and buildings. Just not very much, but it's a small definition here. What I could do here is I could take the baseline data model, say the building one or the device one, which is the one I just had up on screen, and for person, I'm just taking it directly from this Swagger file here, defining a person, which is based on the schema.org version, and I can just generate the ID. Now you will find that you need to, or you may need to, instead of just saying my namespace : the name of my attribute, which is the simple way of doing it, you may need to use pre-existing well-defined IRIs. So for example, temperature, it's much better if you're collaborating and saying, yeah, my temperature is a Saref temperature, because they already create these. So you can modify the file in question, and eventually you'll be able to create the document. So what I can do here, if I just bring up I'll just bring up my little tool. I have got, I'll bring it here, where we gone? Straight into this one. I've got here a Swagger file. I'm just defining various parts of my system using Swagger. If I were to copy this into the Swagger editor, I'll do that just editor online. You see, this is a valid Swagger file, although I'm not actually using things like personal gender within it. You can see I've got various attributes already defined my system, and I can use that to generate something else. Indeed, if I just go back to my tutorial, I can just go. I think it's services NGSI. Here we go. And the name of the file. So if I go back in here, I go ls. So I've got my agriculture.yaml, which is what that was. So I can go /services. NGSI. NGSI. Name of the file, agriculture, ag. So it's trying to. Okay, so I need to build first. Sorry. So it's building my simple tool to get hold of an at context, which it's all it's doing is that you take. If you look at the Swagger file is basically an object which has got keys and values, and it's going to put some defaults for these keys and values for when it's generating my file. So tab. That's the one I've got here. So now it should have actually loaded it. So I can just go generate, and it's just created a file called data models.context NGSI-LD created, and what was a Swagger definition here with all this stuff in it is now defined quite clearly as a load of keys and values. Now, these might not be the right keys and values. I mean, obviously, you may need to edit some of them if necessary, but it will be a good start. And this will be a valid context file for you to play around with. So, yeah, I would always start from defining your world. Easiest way to define your world is to create your data models using something like Swagger. That way, you know that you've got various attributes. You actually properly describe them as well, because we're talking about data sharing here. So it's necessary to describe things for humans as well as for machines. But as you can see from that little experiment, all I needed to do was run a pre-existing tool to create a valid context file. The definition of what you need to put into a context file you will find on the JSON-LD .org website. So it's open curly bracket at context blah blah blah. You can, if you wish, add in additional data about the nodes between the various elements. That's at graph, although that is more advanced. And whenever I've done that by hand, which is saying, when I have a relationship, what do I expect at the end of this relationship? Is it a person, or is it a device or whatever, or what different things are allowed on this on this link between one entity and another? So, having done that, I now have an at context defining the world, which has got all of my attributes set up using names which are well defined. Now, going back to that, that's wrong. going back to that generated. There we go. Generated file. On top of this, I have in some cases. Now I've defined that in the extended file, haven't I? Yeah. Okay. So if I want to get hold of, yeah, there we go. That's the one there. You can see here, I have a Swagger file which is referencing other Swagger files. So, for example, person I have defined using this X NGSI elements to make sure that the URI it comes back with is actually schema.org. Additional name. These are fairly standard names for stuff. This is if you've got a Swagger file, if you've got X dash something, it means it's custom stuff, and this is just custom to help generate my my elements. So, having done that, which actually will take longer than you would like, you have a definition of the world. What we need to do now is to be able to use our short names to map them to these long names when I'm pushing data out into my devices. Within FIWARE, if you've got the you see in the catalog, you've got these 5 blocks. Block at the bottom includes IoT agents, connection to robotics, connection to third-party systems, and there is a common core to a lot of these IoT agents because they're all doing the same thing above the line. For the North Port interaction between the IoT agent and the context broker, there is a standard mechanism for basically just doing the upserts or listening to stuff coming down from the context broker if I've already done a registration. So there is a common library which is able to decide, okay, I want to do this as NGSI v2 or NGSI-LD. If you are dealing with this as NGSI-LD, easiest way to do this is to set the is to use the Dockerized instance as is defined on the right-hand side here. And you can see that I am saying IoT context broker NGSI version is LD. There are 3 supported. There's either V2, LD, or I think it's mixed, where it will default to V2, but you can provision individual devices as LD. The other attribute, which is essential if you are using LD, is that you must have either in the config.js, which is hard coded in the middle of the Docker file, or more likely the Docker environment variables, is to have a path to where that context file is currently being hosted. Going back to that file, you can see, okay, I have this file, but I need to publish that on the web on a public URL, so that if someone is data sharing, I'm data sharing with someone, they also need to be able to access that particular file. So you need a path to your context file. What I do within the tutorials is I'm just running a little web server, HTTPD, just the Alpine version, nothing fancy, so I can actually offer a file so it can be downloaded. There are several other very useful parameters which are not essential but are required in the vast majority of circumstances. The IoTA fallback tenant, if you have any actuators, so devices that actually go out and do things rather than coming in from the real world going into the context broker, the reverse, coming from the context broker going into the real world, you will need to set a fallback tenant, because it is not necessarily the case that the tenant headers are properly configured coming back down, and if you don't place a tenant, it doesn't know which tenant you're talking about. If you set the IOTA timestamp equals true, it will automatically create observed at properties of properties. As mentioned beforehand, observed at, like unit code, is one of these special so-called non-reified attributes. In other words, it's just a key value pair. So there's no need to have brackets and property type and what have you. Observed at is the standard name for setting temporal stuff into your system. And therefore, what you really want to do is use observed at as everything else. The autocast is also useful, which means that if you have something like a 7, it is not misinterpreted as a string. It's set as a number, so you get your types set up properly. How do interactions work with an IoT agent? Well, the easiest interaction to work out is that you work from the bottom coming up. So you start from the device. The device makes a measurement. The measurement is in whatever syntax you've got for your IoT agent, for your IoT device. This means that the context broker is abstracted away from individual payloads. So you could there are multiple IoT agents available out there, so you can pass the data using just ordinary JSON if you like. But equally, if you're in a low power environment, you might want to be using something like Sigfox, which is just a well-defined set of binary bits at the top of a message, another set of binary bits to say the temperature is the lower part, or whatever you define it that way. Or another common one is LoRaWAN, for example. And the IoT device itself sends the reading using an agreed protocol. So if you are sending device over HTTP, fine, we all know what that is. But there are, of course, plenty of other agreed protocols which you could be using. Indeed, if you look on the FIWARE website, one of the more recent Wednesday webinars was about using a blockchain as an agreed protocol, so you'd have an indelible record of the fact that something has happened. Now, obviously, up into the IoT agent, it will receive the measurement using the agreed protocol, or potentially using some sort of gateway in between that and getting the protocol. And based on how that device has been configured within the IoT agent, which itself is a database, it will work out, okay, well, the device called XYZ1234 in the real world maps the URN NGSI-LD device 1 XXXXX. And the payload attributes say T is actually a temperature in our short names, and obviously within our at context file that would be the long names, and it would make sure that the device is the context broker is updated with the state of the device. Now, this may potentially include linking data. So if you have, say, a temperature sensor which is in a room, you might want to update both the sensor with a new value and the temperature of the room with the same value and a link to, and it was received by, provided by the following IRI. Under the hood, all that the IoT agent is doing is it's sending an upsert. The upsert, of course, is one of these batch endpoints, but it means that whether the thing exists or previously or it's new, it will be added into the system. You can see here what I've got here is both a temperature, which is the thing which is changed, but you can also have static data. And the static data in this case is we've got a relationship saying this particular device can be found on in building XYZ. Now, the other parts, the only essential parts for the temperature attribute, of course, type will be property or geoproperty, but that's calculated for you. The value obviously is required, and the observed that is generated by your if you set the timestamps to on. But you can, of course, add in additional static data here. So, for example, you could say, well, I configure my temperature so that it's got a unit code, and the unit code is Celsius. I configure my temperature attribute so to say that for device thermometer 1 in this case, the accuracy is 95%. Once again, you've got a unit code inside the property of the property, because that is a zero to unity value. How is this actually done within the IoT agent? Is that you need to first provision the so-called service group. Now, the service group sets up your entity type, whether it's it's the type of the entity within the context broker, entity underscore type, in this configuration. The necessary attributes, the attributes being the things which are currently changing, and static attributes. Now, static attributes are additional data you can use to query the system so that you can get back the information. So, for example, we're setting a category here to sensor, which means we're looking at we'd be able to retrieve back sensor-only devices or sensor plus actuator devices or whatever. And also, what's the protocol which is passing around? So, okay, we happen to know that this device is talking ultralight. So let's say this is the supported protocol. There is another class of attributes called lazy attributes, which are things like battery level, where you wouldn't supply it normally, but when the device is automatically registered by the IoT agent, it says, oh, by the way, if you ever want to ask for battery level, just ask me, and it will supply the battery level on demand. Reason why you might want to have lazy attributes is because not all data needs to lie in your context broker. If you remember, the idea behind a registration is that you can retrieve data from other sources. And specifically for something like battery level, where every time you check it, it's actually going to drain that battery slightly. You don't want to have it as a standard attribute. You only need to get it when required. So when you are setting up a service group, which is the common stuff I'm after here, so I'm saying that commonly for everything which is associated with this API key, 32170 etc blah blah, then add the same data into each device which is dealing with this. So we know that all data which uses that API key, and I'll show you how the data is passed up in a second, will be recognized as a thermometer, and it'll get all this extra stuff as well. For each of these attributes, static attributes or indeed lazy attributes, you need to have in turn, as we've done with the normalized data entry, a type of property or a type of relationship. In all cases, there's also a value, because this is for backwards compatibility with NGSI v2. So even if you set up a relationship, it will have a value. But you can also add in native JSON types or GeoJSON types. So you could have a type of Boolean. It will recognize that that is actually a property, and it will do the conversion from TRUE to a Boolean true, for example. For GeoJSON types, obviously, it will do the conversion from into a GeoJSON, be automatically defined as a geo property. If you define a geo property, then at the moment the default is going to be a point. Vast majority of geo things is just a single location. So let's say you had a GPS, then the point is going to be where the GPS is going to be coming through on. I am not certain if language properties are actually supported by devices. It'd be a rather unusual situation. I just haven't tested it, to be honest. So that may or may not be supported, but that covers the full range of things you can actually do. Having provisioned a service group, which is saying, in general, all devices of this group have this. You would also need to provision the actual individual device. So I've given this device a completely random device ID, but within the context broker, as you know, entities should be given proper URNs. So its proper name is URN NGSI-LD device temperature 001. And once again, you can add in additional attributes on this level. So you don't necessarily have to define things like temperature on the bottom level. You could actually define it just within this class of device itself. I'll show again. Once again, I'll go through some proper examples. Having an additional thing which you can add on your static attributes is that you can also add in the link property, which or link attribute, which is doing the mapping back to an additional device. So for this particular device, we have a link here which is saying, okay, whenever the device temperature is updated, update the temperature of the building as defined by my static asset. So this means that two things will be updated as once. GPS, as I said, geo properties are a little bit different in that the update of a GPS. Once again, we've got one of these at context files, and they're defining whatever the system is, name of the device, which is agreed with the provisioning, type, which is again agreed from the provisioning. The location payloads are not necessarily going to be in GeoJSON form themselves. So, for example, if you're using ultralight, which uses this attribute name bar attribute value syntax, it is possible to define it's possible to define the attribute as a geoproperty, and it will be attempted to be parsed as a series of coordinates. So a string which just consists of 1335, 50, 52, 52, 51, somewhere near Berlin, will be automatically translated into a GeoJSON point, because obviously all geo properties have to be GeoJSON within a context broker. So that is done automatically. There are multiple attempted conversions here. Obviously, you could put in GeoJSON directly if your device is capable of doing it, but your device is much more likely to be sending, say, a lat and a long as two separate values. There is within the IoT agents a standard Jexel parser, which means you can actually define the lat and long using Jexel syntax. So you can say, I want to get that value from the incoming lat, and I want to put it into that location in my payload, which I then push up to the context broker. It's obviously a variant of how you do ordinary properties. Provisioning GPS devices is just a matter of giving it a value of either geo : whatever, or as I said, the lower example there is going to be using this Jexel syntax, saying that this is an expression which consists of get the value from lat and get the value from long. So it's all updated into the insert. Well, that's enough of a information dump. Should we see some of this in action? So I'm now creating a simple system which consists of a context broker, an IoT agent, and also I'm creating my dummy devices so that my dummy devices go off and do something. See if my farm exists. So I've got a series of devices on my farm, and they're going to be communicating using ultralight over HTTP. If we, before I look into that, I'll just briefly show you that. Is that the wrong one, isn't it? All right, IoT agent. You can see here that in my data model, I have defined my world, which is that file which I generated. I've even added in things like on and off, which are going to be used later on for actuations. And when I create my IoT agent, I have set the timestamps as you would expect, and it's going to be NGSI-LD. There are some settings which are required based on your how you deal with your context broker. So obviously, I'm listening on a certain endpoint to get the default resource, and I'm going to be passing data up into a context broker called Orion. All this information is properly documented in the documentation for each individual IoT agent. There is, as you would expect, a heartbeat to work out what version I'm currently running. I'm currently running version 219 of this particular. No, what am I talking about? I'm running version 120 of this particular IoT agent, and it is based on the library version 219. Version 2 means it supports NGSI-LD. If it's version 1, it would be just supporting NGSI v2. You can see here, I'm going to start off by creating a service with some sort of key, and I'm going, just device, and it's saying I'm listening on this endpoint, and I've got various. I will have various attributes in my system. Having said that, it will say yes, I've created. It means that the IoT agent can do this transformation from whatever I call my device to whatever I do elsewhere. Similarly, if I look at my actual temperature sensor itself, you can see here what I have here is a mapping between object ID and name. So what is coming in from the outside world as T is going to be called temperature when I finally create the device. If I now have a look for the device, I will get rid of the attributes for the time being. You can see that already a device is being created, and it's including all the attributes which I've got in that service group. So it's already set something for all my values. If I were to and of course it's got this it's got a temperature, but at the moment, if I had to go back to what it did beforehand, which was read from context broker, wrong one. Here you can see temperature has not been set yet because we don't know what the temperature is. We know that it will turn up, but it's got not got static data in it at the moment. If I send a measurement, which using this ultralight so-called protocol, what I'm doing is I said I was listening on /IoT/D, which was provisioned in my service group resource, and you can see that I'm also sending this common key, which is saying, okay, well, when I said that, I'm going to build that particular group, and it's also giving me an I, the name of the temperature device. Now, temperature 001, if you had a look back at the provisioning here, temperature 001 is going to be device NGSI-LD 001. So now when we read the context broker, you can see that I've got all my things, and I should have a temperature value. And also the temperature value is saying temperature, and it's got the correct unit code, and just as important, it's got the correct observed at, because obviously that has been updated on the fly as the system has been dealt with. The reason for putting in a common key for things is that you can provision or you can receive data from unprovisioned devices. I've got this thing called motion 3, for example, and I just send C equals 1, right? Because it's got the correct key, well, I can then read in here on type. Is it type thing? It's not what I create it on. It's type device, isn't it? Sorry, not type thing. You can see we've got an array of 2 elements, including this strange new thing, which it's tried its best to create an actual entity within the system. Obviously, if you're using unprovisioned devices, and if you haven't done a mapping of the attribute, it's going to take whatever's coming in, which is generally not that brilliant. But obviously, if I had actually said added in C into my defaults here, for example, saying that actually a C is a count or whatever, it would have come through as a more readable system. The device name is just purely going to be whatever the URN is. This is saying it's a URN, saying it's using NGSI-LD format, and then taking the entity type from the default entity type, and then just sending it as whatever the name has got in directly. So you can see that even if I'm doing something as simple as pushing a string of data into my system, it will transform that into proper NGSI. Now, with proper NGSI, what happens is that something reading this system from above is able to interpret the values according to a common agreed series of terms. So this is just abstracting out. Now, I'm currently just using this, just using HTTP, just sending HTTP command. Realistically, you're probably going to be more likely to be using something like MQTT or LoRaWAN for your data. If you're in the robotics domain, for example, there is an experimental IoT agent based on ROS2 topics. So you can actually you get the data yourself. If you have a problem and you're using some bizarre new format which is not currently covered, you can create your own IoT agent. That's very, very simple as well, because the common bits of dealing with security, dealing with provisioning in a common fashion, dealing with upserts into the context broker is all done the same in each particular example. So we've done provisioning of devices. You can see that the data can also go down through the system. It's coming into the north port of the IoT agent, and it can come. It'll go out in whatever proprietary format you're talking about. So in this case, what you've got is actuation. Actuation is one of the standard forms of registration request. It is the default which is used by Orion LD today. it is probably going to need a little bit of tweaking once the 4 forms of registration are properly defined. It's just going to be a flag, so it's not a major change, and that will be done within the IoT agent code anyway. However, what's happening is that I make a request to the device on a context broker. The context broker says, yes, I've got that device. I've got that data about that device. However, I've also got a registration on that ID to say the following attribute is held elsewhere. So it will then do the forwarding in a defined fashion for an NGSI-LD request. So let's say it's a patch, because we're updating the status of something. So let's patch the status of the lamp to on. Then that will be passed down into the IoT agent. IoT agent will read that, and it whilst that's happening, it will actually say, I've got something to do. It will then set the command itself to a pending state before it will pass it on to whatever the proprietary system is that the device actually deals with. So it could be that it takes a bit of time for the lamp to switch on, in which case the device will be in a pending state for a little time before it's completed. What will happen is that eventually the device itself will receive the command. It needs to send back an acknowledgement. The acknowledgement is read by the IoT agent in whatever this proprietary format is. You can see everything in the cyan is proprietary format. Is then passed into the context broker using NGSI. So there are actually 2 ways which this could be done within an IoT agent. I actually showed this briefly with the examples I was giving on the advanced NGSI yesterday, which was saying that you could also theoretically use a subscription for this. So in other words, what would happen is when the IoT agent, instead of being responsible for the attribute I'm switching on, it would say, okay, I would like to subscribe to changes of the attribute switching it on. And then it would receive a notification. And again, that notification would be the cause for setting to a pending state, passing the data onto the device, listening and pushing it back up again. So both of these are available. It's within the documentation, the subscription mechanism is described as bidirectional attributes. Obviously, both are going to be fully supported going forward, and it's just going to be a matter of, well, if the syntax has changed on the registration, then that will just need to be merged in on the library to be used. To provision an actuator, it is necessary to create a command or series of commands. They're a bit like the original attributes, except, as I said, what this really means is that it sends a registration onto the context broker right-hand side. So you can see here, this particular example, I've got a water sprinkler called device, and it's listening on an HTTP endpoint, and it's got a name. Okay, so what that is passed to the context broker is saying whenever device water 001 is receiving anything to do with properties on or off, contact me. I'll tell you what you need to do. The equivalent for the bidirectional attribute provisioning is, as I said, what you need to do is just set up as an attribute, but you need to have this extra little reverse element in the provisioning request, and it does the same thing. It's just saying, okay, I'm a bell. I want to be informed whenever you think that this bell is being rung. It says filling for some reason. I don't know why I've still got filling on that slide. So shall we see an actuation? Just to make Oops. 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 Just end that for a second. Work out what's happened because I managed to yank a cable out by mistake. So I'm just hoping you're still there. Where's it gone? Ah, there we go. Yeah, me. Okay, so you've currently got that. Right, let's go back in again. I was just reaching over and managed to disconnect my second screen for a second, so I'm not quite wasn't quite sure what was happening. In case you're wondering what was going on, so let's go in and have a look at that device just to be clear. I'll just restart the whole system again. So once again, I can just go into my device, check that it's actually still there, which it is. And then I can create my service group, which is going to give you some default stuff for my device. Should I need it, I can then provision my actuator. I can see here that I've got an actuator which has got the command on, and it's going to be watering something in the barn. You can see that there's you can provision multiple devices at once if you wish. Once again, there's a postman collection you can use to do all the various CRUD actions here. Now, if I, where are we? Look at the farm. I can just audio's off. There, audio's on. So I can look at my farm, and I think if I provision my actuator, you can see that's the wrong one. That's the right one. Okay, so I'm just sending something to water 01. And you can hear that my water is now very loudly. You've got feedback on, so it's sending stuff through. I set that back to off. Cuts off my water. So I can actually just use a simple patch request to make my my changes as necessary. It's obviously, if you wanted to do a more complex actuation, you just send some data as part of value. So you could have robot turn right by 30 degrees, move forward by a certain distance, and so on. I could do the same thing. I think this is I don't know. Can I do that? I'll have to. I'll just restart to see if this one works. I think this is also down as water 1, so I'll just restart the thing again. Clear out the data. I'm going to get all the audio on as well. So once again, I just provision my service group. And this time I'm going to provision an actuator using reverse bidirectional. And it should be the case that when I update the value, oh, this is water 1, it's water 2, so that won't work. I think it's water 1, wasn't it? It was device 2. All right, so okay, so I haven't quite set that one up properly. Is water device 1? Okay, so it's not. I've got some sort of mistake in my provisioning there, but I'd be able to retrieve the actuator as necessary. When you retrieve the actuator, you will get a couple of additional. I think I'm back to the slide deck. Where is it gone? There we go. So you send a subscription. When you send actuation on, say, on, it will actually update 3 attributes. One of which is the this pending thing, but it also will give you the result. So that's going to be on_status. It will also give you the result of the element in question. So that is basic use of devices. You can see it's all abstracted out of the system below. Now, you are able to extend this to right. Okay, so which way around is that one? Okay, so I'm now going to imagine I've got data into my context broker, and I want to extend it into my existing file management system, my existing product. So we're going to try and get the data from the context broker into another product. You can do this in many different ways. You could, for example, if you're going from a legacy system into the context broker, I can upsert. I could do, let's say, I've got a database, I've got some sort of trigger on that database, and then when that happens, I just send an NGSI request. That will work perfectly well. I could upload a CSV file, and indeed there is an example which is based on an actual working water-based FIWARE system, where the legacy system is generating a CSV file. You can parse that, work out what you want to do, and you do this upsert. The more you need to do custom work on the system before you do the upsert, the more likely it is that it becomes a custom web component that you're going to be dealing with, rather than an existing IoT agent. You could, of course, have something like a cron job, which we then work out and then push data to NGSI. The little bit of code on the right is actually going the other direction, and that is a case of, okay, I have a registration. No, registration, subscription, and I'm listening on the subscription endpoint. And then whenever something comes in on my context broker, I will be informed, and it will then push the data back into I think a MongoDB database. So it's possible to go the other direction as well. Obviously, context brokers don't live in their own silo. That's the whole point of this. So you need to have little connectors to push back if necessary. So extended legacy systems via registration. Tell me about X. What I would do here is I have a system which I want to connect to an existing context broker. Okay, what I would need to do is place a registration onto my context broker to say this connector is going to be able to, in this case, listen to the following following attributes. It would then be a case of, if I do a patch onto my context broker, it would actually realize that the third party has got the interface to do this, and it would pass the data down the system. You saw how this worked when I was describing registrations 2 days ago. The registrations is just effectively always going to be a duplicate of the initial request passed on to another interface. What we have here in the top right hand corner is that there are, in this case, it's listening to both the attrs patch and the ID get to get the data as NGSI or update the entity in the third party system as necessary. When you're doing the get, it does whatever's necessary in your actual system. I don't know what your system actually does, but at some point there will be a response. The response will need to be formatted as NGSI, and then it's returned back up to the original context broker. Extended legacy systems via subscriptions. Once again, you have a and this is very common with things like data persistence components, which is what we'll be dealing with in the next section. Once again, you will need to listen on a well-known endpoint to retrieve the data for a notification. Data from notification is always going to be in a well-structured format. So you can, in this case, it's going for each element in data body, rec.body.data to actually go through something, do it. And then the important point for a subscription is that having completed what you need to do, or possibly if you're trying to do stuff asynchronously, you could do it even before you've completed all your processing. You must send a 204 HTTP response to the notification. Otherwise, it isn't believed to have been read properly. Ending this section, hopefully by now you've got the idea behind JSON-LD, NGSI-LD, but you can see the specifications are already in there. It should now be a lot clearer why things like smart data models are going to be really useful for you, because they can do all the legwork of generating that at context file so that you can use your stuff itself. There's an example of how this works within smart cities as an example video. I think we've got one on how to do this in water as well, possibly one in farming as well. So there are multiple elements which can be dealt with there. So that is the end of this particular section, at which point I will now see if I can get back to the main screen and see if we've got any questions. So any questions on how to connect your IoT agents in? There are multiple videos on this which are available on the FIWARE website, and obviously all the code behind this is also available. Where I'm working from is, I'll just paste this in the chat. All the code and examples are linked directly into the chat. Sorry, that's not the chat. That's the Q&A. Sorry. Paste that in the chat. You'll find a lot more details there. So if there are no further questions, I would suggest we take a short break until 4:45, which is well, 4:45 for me here in Berlin, which is a 10-minute break, and I'll be back with you after I've had a cup of tea. So I'll see you in a bit. Try that again. Welcome back, everybody. Now you can probably hear me. For the next section, I'm not actually going to be dealing with a slide deck. I'm going to be actually doing some of the live demo stuff myself, just to explain how to connect to one of our data persistence components. There are multiple data consistence components within the FIWARE catalog, and frankly, the mechanism which is used to connect is the same in every single case. So if you can do it using one, you can do it using any of them, frankly. The first demo is just going to be using one of our components called Quantum Leap. So that what that does is it persists data to a time series database. Now, why do you want a time series database? You probably want a time series database because you might want to be able to display a wiggly line on a graph saying this is what's happening. Indeed, there are members of the FIWARE community who can make money out of packaging this with their say smart city solution. So you can see that this is actually something which is really, really worthwhile. But fundamentally, if you want to get your data into a time series database or a Postgres database or a MySQL database or whatever, you're following the same steps. And something which is necessary in the first place, which is what we were covering in the previous hour, is that you must have some changing source of context data which is being pushed into your context broker. That should be taken as a given. Now, if you look at the tutorials, either the NGSI V2 tutorials, the NGSI-LD tutorials, what happens is that the first thing which happens with that little setup script is that it obviously starts up the various elements, but it also does all the provision devices. And I thought I'd just briefly recap going through the how the provisioning actually works with some real live devices. So looking on screen, you can see that again, this is an annotated file. It's only 4 or 5 requests. And what it does is, first thing I do is I set up multiple service groups. You can see that the service group here is called services, and each one is got data in it. So all my temperature sensors will have an object ID T. In other words, T/something's coming in, and it will always map to temperature. And they have various bits of static data, which is saying, yes, I'm a temperature sensor, I'm a sensor rather than sensor actuator or whatever. And it's repeated for each of my groups of devices. So I have temperature sensors, I have soil sensors, I have a filling level sensors, and I have some abstract devices. These are the ones which are going to be the anonymous devices, which is going to be devices, going to be things like pig collar and animal collar. If I have anything which represents the API key 110990, then that will be taken in as something which is reading heart rate and location, for example. Now, I think this is done two separately. One of them is for the pigs, one's for the cows. Now, what else we've got here? Oh, yes. And then, of course, we've got that water sprinkler. The water sprinkler here, we're defining with calling it water. And again, it's got commands on and off. And you can see that this is all generic stuff. We've got a tractor as well, which is both, you can see from the things, both an actuator and a sensor. You can do both. So you can send data to the contractor, say, go off and farm that field, or the contractor can send data back saying, the field has now been ploughed. So we have either actuators or actuator sensors, or combination thereafter. Having done my groups, I can then just do all my devices in one lump. You don't have to do individual device one at a time. You can do groups of devices. You can see the way I've grouped these is I'm saying I've got devices per farm. So each farm has got a temperature sensor, a water sensor, a filling sensor, and a tractor. And again, what we have here is just differing, in this case, differing endpoints where the actuation might be going. So tractor 1 is going onto IoT sensors tractor 1, whereas tractor 2 is going onto IoT sensors tractor 2, and they would have potentially have different buildings or different static data they are associated to. So you can see that the controlled asset is changing in each case. If I that will be additional data for each system. Having done that, I am also updating the static attributes of that link ability, so I can update my devices with my generated data, which you can see. What I have here is this link business. So it will say, okay, the device which is currently around the neck of cow 1 is measuring the heart rate of cow 1. So you can do both of these. So you can see it's a matter of just doing some fairly standard initial provisioning before you go off and do something else. Now, one thing about all these tutorials, which is that because they are teaching tools, they don't bother with any proper data persistence. So every time you start off from nothing. Obviously, what I would do in reality is if I had a MongoDB database, you would instead of having your volumes randomly attached like that, you would actually attach to a real location. So that if there was a problem like pulling a cable out, like I did 5 minutes ago, then when you come back, you'd actually have the information you've got beforehand. So you can see there are some bits which are common to every system. This is always going to be common. You're always going to have that at context file. You're always going to have some sort of need for data persistence and some sort of IoT agent. Having done that, you can just add in as many, and of course, this is the thing which I'm using to generate my devices. So having done that, you add in whatever FIWARE components or custom components you require. Now, I have got here one of the elements from the FIWARE catalog called Quantum Leap, and you can see that all it's doing is it's actually persisting to create DB and also uses Redis. So it has a couple of dependencies. They are also placed in there. Now, in order to get something nice coming up on the screen, we're also going to generate a Grafana instance as well, but this is coming later on. Within your context broker, it doesn't matter whether you're using Orion as your context broker, Scorpio as your context broker, Stelio as your context broker. It doesn't matter. These are all, in all cases, it's the main interface. For Stelio, it's the API gateway. For Scorpio, I think it's called Scorpio in this one. Yeah, Scorpio label. Here we go. And then whatever the other dependencies which are required for that particular system. So again, looking back at Orion-LD, that would have a dependency on having a MongoDB database, which you've already got. But Scorpio needs Zookeeper and Kafka, and its backing database is a Postgres database. You can just steal these configurations directly just to play around with them. So we can start up quite easily, which you can see whilst you've been away, I've just started these up, and they're still running. And obviously, I've got a health check in a lot of these as well, just to say yes, I'm still working. I'm still working. I'm still working. What does that mean? Well, if I go over to my devices, what I can do is I can start my tractor, and it will start sending data into my context broker. You can see because the way this particular application works, as soon as the farm wakes up, then it starts sending data all over the place. I can do things like I can modify the remove hay from the barn and things like that. You can see the send. You can see the level of the filling sensor is slowly depleting as well. All this is doing is sending whatever the protocol is of your devices where you're setting up the world. And because I've provisioned my IoT agent, that means stuff is getting into my context broker. So I can actually start looking at my context broker as to what's going on. Let's have a quick look at the filling station, which I can do here, which is where is this filling level station, isn't it? Just a second, what the thing is. Filling level sensor, not filling level station. You notice if I do this, I'm not going to aggregation data. I will not receive an entity, and that is because I'm doing this on an NGSI-LD tenant. NGSI. You can see that this is automatically multi-tenant, and if I don't specify a tenant, it's going for the default tenant. And because I've placed this in a specific tenant, it says I don't have any filling sensors on the default tenant. I'll put that back in again, which is, I'll just show the code. It's just a header file. Here we go, NGSI-LD tenant OpenIoT. If I do that, then I can see that I've actually got my device. Now you can see that what I've got. Oh, I'm trying to move that up a bit. Oh, that one. There we go. You can see what I've got here is because I've got the commands add and remove, and I've started removing some of the hay from the device. You can see that when I added a command called remove, it has actually added 2 new attributes. It's registered remove as a command, but it's also added in a remove underscore info and remove underscore status. And you can see that having done a remove command, it's already updated the status to say, well, as far as I'm concerned, this is a command status. This is actually I'm doing key values. I'll get rid of the key values as well for the moment. Body parameters. This is in full normalized format again. So as you can see, the remove info is an object, and the object here is it's actually a JSON literal. It's saying this is of type command result. Because and it's just said the result, which when I successfully sent the command, its result was remove OK. So we know that I've successfully removed stuff from the barn, and you can see that the status of the so that would be whatever the response from the command is, and the actual status of it was OK, done. You can compare that with the add attributes. I haven't added any hay back into the barn yet, so at the moment the status that it currently knows is unknown. okay, we don't know whether this command has worked or not because it's never run, and it's got a default value of a blank space for the command result. One thing which you should remember is that nulls are not directly supported by NGSI-LD, and therefore you for a default you're better off having a blank or a space or whatever as the command result. So going back to Quantum Leap, this is how you connect to any external system which needs to be informed of events. This is saying, notify me of all feedstock changes. Fine. So we're changing the level in the barn, and more importantly, the URI, the endpoint that it is being sent to, is in this case Quantum Leap v2 notify. But it's also saying I want this in application JSON format, so I don't want that context thrown in there, and I want it in normalized format. And once again, of course, you've got the context in the body here, so I can create one of those. And I can also do the same thing for, say, the location of the animals. Same thing. You will have the series of devices. The devices will, you'll be watching certain attributes of those devices. So in this case, we'll just want to be notified whenever the location, the status, or the heart rate of the animal has changed. But the notification also includes that. So one of them is the trigger, and the second one is what data am I passing into the system. Now, this particular one has also got a throttle because we don't want to send the data too frequently, so it won't fire too often. Having done that, we can check to see if the subscription is working. Again, because we're looking on this particular tenant, we're looking for changes on that particular tenant. When I did the post, it had this tenant header in there as well. It's only for the one particular user. And if I send that, you can see what's happening now. At the moment, you can't see any data being sent. I think I might have made a mistake on that one. But let's just send some samples through here again. Let's remove some hay. You can see the filling level is slowly dropping. Now, send that. That's interesting. It's not giving me any data. So why is it not giving me any data? Oh, yes, it is receiving data. If you have any doubts, the thing to do is to up your debug in your components and see if it's actually retrieving any information. And you can see here that, yes, I am getting back information about that data. You can also have a look in the context broker, which is version 1.0. You can see it's saying successfully sent the notification about various devices. You can see it's sending data through. When you have a situation like this, you've potentially got problems either from your device to your IoT agent, to your context broker, to your wherever you're subscribing to. So it's worthwhile checking each part of the chain to see, okay, is my IoT agent receiving data? You can see the IoT agent is receiving data. Humidity file went through there. It's now updating some animals, some cows, and so on and so forth. Obviously, normally when you're running this, you wouldn't have full debug on, but the tutorials do actually have full debug to work out what's coming out there. Now, within this component, I should be up and running. Yes, we've got version 0.83 here. You can, for example, the filling station 1. Why is it not found? It's not found the query. Is that a different URL? So what's the name of the URL? Just a second. Go back to Quantum Leap. What are we calling this? I'll see if I can do that for a different animal. Oh, it's probably not filling, that's why. Let's look at an animal heart rate. I've not found cow 01. What cows? I'll just have to work out which devices I've got. What's the name of the device? So let's look at some devices. Where are we? Should exist. Okay, so why is it not working, headers? Open IoT seems to be working. Okay, so again, the demo is not working for me. Not quite sure why it's doing this. Recently changed from one PC to one Mac to another, so it's curse of the live demo. I think I'm just going to get hold of the existing working video instead. Hold on for a second. I'll just stop presenting for a second and get the video. Oops. Where's it gone? Right. Found it. This is the advantage of having made a recording just in case things go wrong on the live demo. So here's the deep dive filling station. Moving on to a deep dive example, we're going to show how to get data into a system, which means that in this particular case, we're going to have an NGSI-LD context data
coming out from our devices. As it happens, our devices are going to be on a smart farm. They will go into an IoT agent, which will obviously push out data into NGSI-LD, into an NGSI-LD context broker. So this means that we have a common interface. We have the context broker NGSI-LD interface for all the information we are gathering. The stuff at the bottom of the stack isn't particularly relevant to what we're doing here. We'll need to raise an NGSI-LD subscription, which means that we have a well-known format for how the data is coming out when the data comes through, and this will be able to persist data to time series data. It would be possible, if we wished, to raise the NGSI-LD subscription to a proxy, which means we would have an opportunity to manipulate the data before we proxy it on to Quantum Leap. We might need to do that in an NGSI-LD scenario if we wanted to do an expansion compaction operation, changing the values of the attributes before it reaches Quantum Leap. Now, Quantum Leap in this case is our data persistence mechanism. It is a separate component which is there purely for pushing data from one place to another. It is important that you must separate your concerns into multiple microservices. At this point, Quantum Leap is pushing to CrateDB. CrateDB, the latest version, again, is Apache 2. So again, you've got no issues on your open source database, and it is usable as a data source for Grafana. So you can see we're splitting up the various different elements into different components so that we can follow a chain of persistence. And finally, we'll get round to displaying the item on screen. Let's have a look at this in action. So I have a little little tutorial which is running the various elements of my system. If we have a look at the Docker Compose, you'll notice that we have got, where's this thing? It's down. Grafana. We've got, when we are loading up Grafana as an other service, we have additional plugins which we are loading. We're loading in the Grafana map plugin, the clock plugin, the world map. This will become important when we go through later on in the system. Now, within Quantum Leap, it is saying I will be persisting out into CrateDB. So it's important. So you can see how the data will flow from A to B to C, and Quantum Leap is going to be our think in this case. Okay, so we've now got the smart farm up and running, and we've got some data coming in from our devices. There's no real need to know what the devices are. This is using ultralight, but it doesn't really matter. You've just got data flowing in to your context broker. You can see I've got pigs and cows moving around on screen, and I want to be able to track these in real time. We need to check to see that we've got the thing up and running now. In order to get data into Quantum Leap, you need to create a subscription. This is an NGSI-LD subscription here, and we'll start off by showing uploading the filling stock. Now, it's possible to have a more generic subscription. This is just putting the stuff normalized NGSI-LD format. And of course, you have your at context in there as well. This is just going to update the filling sensor. Let's see what happens. It's created a subscription, and again, let's do this the same thing for our animal location. The animals have got type of device. and you can see that we are watching location, status, and heart rate. When I provisioned the devices, the filling station had a static attribute, which also would have a location. When you're typically with a system based on FIWARE, you're talking about assets in the real world. It's therefore necessary to be able to locate these items in the real world, or potentially have a, say, some controlling asset, which is saying, I am actually within building 1 or whatever. Now, this means that when you have stuff, you will be able to display a map with the locations on it. For the actual animal collars, it's a little bit different in that there is a device, try and find it, there's a temperature sensor, here we go, device. There is a device service, and the service itself is passing in GPS location as a location. So it means that within the context broker, you've got a location. This should be persisted and read by our subscription passed on to Quantum Leap. As we can see, the filling sensor has been notifying. This been sent so many. This has been sent 9 times, and the other one has been sent so many times, and so on. If you have a large number of varying data, you'll need to throttle the values which are received. So this is going into Quantum Leap. Quantum Leap itself. See if you can see the logs. I've got the logs running. It's taking a bit of time to come up. There we go. Quantum Leap. Quantum Leap itself is receiving. You can see it's receiving the data. Now, there's a reason why when you set up Quantum Leap, you might want to have a Redis database in its front end, in that you don't want to overload your services. So at the moment, we're reading in several positions of cows or pigs, but you can also make requests to the system directly to ask for time series information. If that information has already recently been received, it may use Redis to get hold of the information rather than go for the database. So we can see what has actually been happening with our system by, say, retrieving the last the first 3 samples from our filling sensor. Let's see, is it actually sending me data for the filling sensor? It's thinking about it.
I think this is because I have changed the name from filling to filling level or something like that. So.
Oh yeah, we get no records found for the filling sensor because the filling sensor has not been. But what about if we were to look for cow?
That's what I tried to do last time.
Instead.
It won't be cow's filling won't exist because it's cow heart rate. There is a.
Think about what's going on.
There is
eventually we'll get hold of some data. I've not found the cow either because I put the name wrong, I think. So you can also go direct to the CrateDB itself to do queries. This is effectively what the Grafana database will actually do. It's actually going to retrieve information direct from a table, which is going to be based on the NGSI-LD tenant or the FIWARE service name. It's called OpenIoT, and this one MT is just a prefix, and it will receive data for a specific type. Going on to Grafana. Grafana, first thing you need to do is to configure your data source. Now, the data source in question is not, it's a CrateDB data source, is not one of the standard ones you've got. However, it is the equivalent of a Postgres. So I need to get my values in there. So just a minute.
This is just a default Grafana instance, and I'm trying to find out what the
it's listening on the
CrateDB ordinary port.
It's listening on the standard CrateDB host port. It's going to be called CrateDB because I'm running this within its own network. My database is OpenMIT. I have a user called Crate, and I have no password. Stable. So you can then test to see, can I actually connect to the data source? And yes, the data connection is okay. At this point, because we've actually got the data in our dashboard, we can say choose a visualization. You have a range of visualizations available here. Obvious one is to go for a graph, and the graph will give you a little wiggly line. At this point, you would need to connect your table to work out where we're coming from.
Nice thing about this is it does give you feedback when your thing's wrong. I now remember what I did wrong. I'll tell you after I've finished the video.
Now, the time column which Quantum Leap saves is called time index. At the moment, for the NGSI-LD data, it's actually taking the data subscription, but it should take the observed at. And then finally, if we go for an entity ID, column unknown, value is unknown. Now that's because it's not value. As I said earlier, you can transform from you can transform your data if you need to in a proxy before you receive the subscription. It's called heart rate, isn't it? And we can actually give it an alias as well. I can give it an alias of value. And eventually, as you
if you look on the right of the screen, you can see the values
coming on the side of the screen. Our cows and our pigs are now showing heart rate for the last 5 minutes. You can see that there's various spikes, and you can also see that the typical cows have got a lower heart rate than the pigs. The pigs have got just over 1 beat a second. Now, it is various visualizations are possible. If instead of getting a changing value on a screen, you can also format this as table data, which would then be displayable under a different sort of visualization. Let's add a couple of extra columns. Now, the location is standard naming for NGSI-LD. It is preferred naming for NGSI v2. But the value which this particular plugin I'm doing wants to call it GeoJSON. And we also want to have various types. Now, entity type is what is called in the database by Quantum Leap, but it is actually the type attribute. And you can see nothing is happening here until I move on to the visualization, where instead of going for a graph visualization, I can actually go for a map panel. you can then see that my devices are being displayed as a map layer because I've got a different value. And indeed, if I move the screen up properly and display my screen, I can actually see that my values are coming into the system. Let's zoom in there rather than change the defaults. You can see that my cows are based in Berlin. Oh, apart from one of them, which has been escaping. Now, this is the sort of information you couldn't easily get from the screen here, because you can't tell that one of these pigs or cows is actually in a completely different location to all the others. You need to choose the appropriate visualization to work out what's going on. You can, of course, also do things like thresholding. You can see what the values of the various heart rates are on the screen, or you could even add in colors.
So that was the working version of the tutorial. The issue I was having is I'm misnaming filling station. If you notice, in both cases, I called it I think it's filling level, and it's now called filling level sensor. And obviously, I haven't updated the postman collection to get to work all the time. Anyway, as you can see, it does actually work, because I've already got a working demo rather than getting stuff in beforehand. Now, what I was showing there was actually not, well, in the main, wasn't FIWARE. It was a matter of getting out of a context broker into a component which can then do something on screen. Now, this is obviously, if you think about it, we are defining our Lego brick. And on the Lego brick, we are defining that interface. What actually goes outside of that is where your application would go off and do whatever the custom logic is. Okay, we connected to a Grafana instance, and you can see we could get hold of the database. That's moving out of the context broker into additional components. The key takeaway here, and I'll just show one more pre-recorded demo. But the key takeaway here is that when you are getting events coming out of your context broker, you always use this subscription mechanism. There are multiple components within the FIWARE catalog which actually work with this. Not all of these have got demos which have necessarily been done with NGSI-LD. So the final little demo I'm going to show is NGSI V2 rather than LD, but the same principles apply. I'll just bring up the bits and pieces I need. Which is
So, okay, let's...
Oops, sorry, wrong one. That's what I wanted. No, sorry, I can't find the thing I'm after. Wait a second. Oops.
So, okay, let's start. My name is Fermin Galan, and I'm one of the developers.
That one there, sorry. I'll do it again. Video. Bear with me whilst I'm finding my my way again. That's the one I want. That's the one I wanted.
Very, very broad.
Right. So this is going to be an example of another example of data persistence. So it happens to be using V2 for these subscriptions, but you'd be using LD if you're using LD. This is an example of how to do persistence with a component called Cygnus.
Okay, so let's move on to looking at something which is part of the FIWARE catalog. We'll start off by looking at the Cygnus, which is based on Apache Flume. Again, you can look at the diagram on this page, and it looks just the same as my simple example, except it's now part of the FIWARE catalog. This one is based on Apache Flume, which is a mechanism of getting data from A to B, collecting and aggregating log data. And the important thing to note about Cygnus is that Cygnus is listening on separate ports for each database that it supports. So in this case, we're going to push something to MongoDB. It's going to be on port 5051. It would be a different one if it was, say, to HDFS or to DynamoDB or CCAN or whatever. And it's configured by config files. Now, it depends on your personal preference as to whether we are you prefer to do stuff graphically or you prefer to do stuff config as code. And the idea here is that it's all done by config files. Going back to our Docker Compose, find it here, it's Cygnus. Okay, so Cygnus, this is the configuration I'm using for Cygnus.
Cygnus
and I'm listening
V2 rather than Cygnus LD.
Configuring a specific port from MongoDB. There are a large number of configurations you can go for, depending on whether you want to do it by Docker or you want to do it directly from the files. And it depends on, do you want to split the data by service? Do you want to split the data by entity type? Do you want to capitalize things? You'll have to look in the documentation to find out the full stuff here. And obviously, it's all based around Apache Flume. So if I look at my Flume here, I can see that because I've actually set up Cygnus, again, just looking at going on to the version endpoint here, just do a get. I can see that Cygnus is running, and I'm running the latest version of Cygnus, which is 1.18.3. Now, from version 1.18 onwards, Cygnus is capable of using listening to NGSI V2 subscriptions, and therefore it's the modern way of doing things. So we no longer need a legacy flag. When I create my subscription,
there's obviously things have moved on since the original demo, and now there's this NGSI-LD equivalent to this, which actually is it's a separate Dockerization. So everything I was saying about Cygnus is just Cygnus LD. So it's the same idea. It's a subscription.
You can see it looks remarkably similar to the previous subscription. However, in this case, I'm going to put some use a service path. I'm going to put the my device's data into a system.
That's NGSI-LD tenant.
You should be careful here in that, because I've got a very, very broad query, it's going to go to log everything. So I send this again. And it says, yeah, subscription's been created. And then you can check the subscription. So I always do this. Is the subscription working? It probably won't be working perfectly well to begin with, because I've not actually done very much with my device data. Last success code is a 400, which is an error, which if we think, that might be a bit odd. But the reason for that is, of course, because I've not actually started up my devices. If I go to my device monitor, I can ring the bell, or more likely switch my lamp on and open door. You can see that there's a stream of data going down. This is a set of dummy devices using ultralight, and it's now getting into the system. If I now look into Kitematic,
if you're just looking at the logs,
move this across. Kitematic is now receiving a load of data, and you can see all the information is coming in. It's listening to that port. It's got a lot of debug in there because I've set the debug up so high. But now, if we go back to the subscription, you can see that the subscription is now saying code 200. So don't worry if you're initially surprised about the data, because it's saying there's nothing there. You know, the data has not started flowing yet, rather than it's definitely broken. But you do need to look at the logs and the configuration in order to get this to work. Going back to Compass, I think, can I refresh at this point? I have to restart. I can never remember. No, here we go. Yes, we can refresh. You can see there are a series of collections within the STH_OpenIoT database. That's the default prefix which is used, and you can see it is actually logging every single attribute. It's logging things like the fact that it's supporting the URL 20 protocol, or to control define the device itself. Whereas what we would probably only need is actually the.
So you can see that doesn't really matter which component you're actually using. What we're doing here is we're leveraging whichever components we've got in the catalog, or whichever custom components we're developing within our own system, in order to do the job in hand. It should be quite clear now that the way that you were usually combine with a legacy system or a data persistence system or whatever is via a subscription. Now, there are other components in the FIWARE catalog, and I'll just bring up the FIWARE catalog briefly. I'll just get rid of that for a minute. You'll find the full list of the FIWARE catalog on the FIWARE website, and indeed for the technical followers, we'd actually just go directly to GitHub, FIWAREcatalog.org, or you can see there's a wide range of elements you can steal. Now, if you take, for example, here CCAN, extension CCAN, that is using the get endpoints to be able to display data in CCAN format. Fair enough. Same with something like WireCloud. WireCloud is using the get endpoint to be able to display data in a tabular fashion, or various mashups you can get up on screen. But it could also use the patch endpoints to be able to, press a button and do something. You move down to, say, Cosmos. Cosmos is doing big data analysis, so it needs to be informed when things are happening. When things are happening, well, that's going to be a subscription. And I've shown you basically the same demo twice, once using Quantum Leap, once using Cygnus to actually say, hey, something's happened. I need to be informed. Now, what the big data analysis can also do is it can push data back into the context broker. It can use Orion as a sink. And that obviously is going to be one of these Upsert endpoints. So you can see how everything connects backwards to where we started. That effectively, whenever communications occur from the context broker, it's a subscription. Whenever communications occur to the context broker, it's the Upsert. Now, obviously, registrations have their place, but that's when effectively the context broker knows that somewhere else is dealing with it. So every single one of these around here has either got is either listening to a subscription in the well-known format, or it's got the ability to push data into the system. So let's take, for example, Corrento. Corrento is used for adding stuff into making your cameras into a device. Effectively, it's looking in image processing streams. Well, that raises itself an event, and that can then push something like, let's say you've got an event, you've got the image processing to work out, this is a number plate. You could then push that data into the context broker. This is what I have currently observed. That is going to be an Upsert. Obviously, we've mentioned the connection to IoT. Robots is just the same. As I said, the ROS2 stuff is going to be working in just the same way as the others. The majority of the elements on the right-hand side here are going to be agnostic, because it's security elements. But for all of the others, you will find that there will always be some connection to context. So that will finish this particular section of the presentation. Now, what I prefer to do is at this point is to finish the teacher-student part of this session. Take a break and go down into the tables of the of AirMeet. And it's going to be a matter of meeting you individually or in groups or whatever. If you've got a working system using any of these tutorials, now would be an excellent time to quiz me on why they're not working. In most cases, I will probably be able to get the answer, or else I'll work it out fairly soon. We can actually try and move things on properly. So if I ask my colleague Andre to terminate the main session, I would like to meet you on the tables in a minute or so. So over to you, Andre. I haven't got the rights to push us to the tables yet, you see. Depending on how long this takes, the alternative is for people to start raising hands, and they can actually start joining me on the main stage to work out what their issues are. So I'm being asked, do we need to press pause? I don't know. I think you can end the session, Andre, if you want to show your face. I think you can. Yeah, try pressing pause and see if we can pause the sessions. Right. Obviously, this technical difficulties in going to the tables. How many people we've got left here? Yeah, most people are just playing left rather than actually got to the table session. So, given the fact that for whatever reasons tables aren't working, if anyone's got any direct questions on how things want to go, could you just raise your hand? I think you can raise your hand is one of the options. Is it reactions? And we can I can bring you up and you can actually speak directly, because this way we can try and sort out any issues. What I was trying to do, and well, Andres turned up. What I was trying to do was to pause the session. Then, if you look at the top of the screen, it said lounge. You can click on there and you can get to the tables. It's just a way of actually getting more of an interaction, talking, rather than just me shouting over the internet for 3 hours. So either someone should try and raise their hand. I can't remember how you do that. Can you turn audio, not present to audience? Is it reactions or something else? I can't remember now. So that they can join us on screen, or we can attempt to go back to the tables again. So if anyone wants to give us a reaction, or oh, here we go. Someone's doing some comment there. Oops, no, that's wrong. Exit full screen. Problem when you're trying to do stuff with technology. No, that doesn't help. No lounge option visible on my screen. Well, that's not going to help, is it? Jem, could you try? Can you raise your hand at all? Is there an option to raise your hand and join us in the place? Because I obviously haven't configured this session. Normally it's a possibility to do additional stuff. So there'll be sessions, reactions. Or if that's not going to work, it's not going to work. In which case, the thing to do is probably just to continue by typing questions. But that's hide panel, that's polls, people in session. So you can at least react anyway. Can we schedule a meeting? No, we can't. Okay, well, this is somewhat annoying because normally the tables have been set up for this. So I honestly don't know how that's supposed to work, because it's not my tool, and I don't think Andre knows either. So it's going to be a rather quiet half hour. Okay.
Yeah, I'm running through settings to find.
We're going to try and find out what's going on. In the meantime, we have to do the old-fashioned way. If you've got a question, you can start typing furiously until we can actually start doing this talking properly. But I think it's a matter of how this session has been set up, because normally by this point people have got lots of questions on how they're getting things to work, and we can try and set things up. Or for that matter, Andrea, could you just bring various people on stage? I'm not sure, because I don't have the rights, because I'm not the host. I'm just a speaker.
I'm looking for that. So for sure, hosts and speakers can talk.
Yeah, we can talk, but we're not bringing anyone else on stage. I think we just slowly going to dribble off to the end, which is probably not the best way to do it. But hey, we've tried.
So co-hosts, hosts and speakers.
It says here manage. I can manage raised hands. So if someone can raise a hand, they can join us on the main session. Again, I'm not an ordinary user, so I don't think I've got the raise hand request.
Yeah, raise hands request will show up here. You can invite them to the stage. So
if anyone wants to start doing stuff interactively, you're going to have to do the raise hand bit. But I'm not quite sure where you do that on the bottom, because I haven't got the option. I've got the reactions, and I haven't got a raise hand option. So that's a shame, because normally this is set up so that we can actually do the interactive bit, but it doesn't look like it's going to be working.
Okay, what can we do?
I think I'm afraid we're probably going to have to wrap up here if it's not going to work, because the technology is not conspiring against us. The only thing which I can say, apologies for the the way things have ended out at the end of this session. If you have any direct questions, obviously the best way to do is to contact me via LinkedIn, and I'll take it from there. But in that case, I think it's probably best to wrap up for this evening, and hope you enjoy the next session, by which time we'll hopefully have sorted out any technical issues. So sorry about that, but thank you very much.